All right, last lesson was on adding polynomials. Now we're going to start to multiply polynomials together. So we're going to start by multiplying by a monomial, meaning a one-term polynomial. So the multiplication is going to be by just one thing. Could be something simple, could be something a little bit bigger, but it's just one term that it's being multiplied times everything. So a good way of thinking about today's lesson is kind of like distributive property on steroids. It's a big version of distributive property. So the idea is you're going to take this monomial, this single term, times each of those pieces on the inside, and then combine any like terms together if needed. So the way to think about it is the numbers get multiplied, the exponents get added. Remember our exponent rules from Unit 4? When you're multiplying something with the same base, you're really adding the exponents together. You're telling me how many x's are being multiplied. Here I had 2 x's, here I had 2 more, so that's a total of 4 x's. So for this first one, we have x to the first times 5x to the first. Well, that's 5x to the second. I have 2 x's. Then I do x to the first times x squared. Well, that's 3 x's being multiplied, so x to the third power. So next one, x to the first times 4x squared would be 4x cubed. You're adding You're adding the exponents of those x's. Then x times 3x, well, that's 3x squared. And then x times 2 is 2x. Now they start to get a little bit bigger. We're just multiplying by more complicated monomials. So I have x to the first, y to the first. So negative 2xy times 2y. Negative 2 times 2 is negative 4. I just have 1x, but I have 2 y's because I have y to the first and y to the first. Then I do negative 2xy times 4x squared. So negative 2 times 4 is negative 8. X to the first times x to the second is x to the third. And then y to the first. All right, so now we're going to kind of take a little bit of today's lesson and combine it with yesterday's lesson where we're adding some polynomials together. So all we're going to do is take that term out front times each of the terms on the inside, and then we're going to come back and combine any like terms we might have to do. So negative 3g times 7g is negative 21g squared, because I have g to the first and g to the first. Then negative 3g times negative 2 is positive 6g. Now I'm going to multiply each of these times 3. So 3 times g to the third is 3g to the third. 3 times 2g is 6g. 3 times 1 is 3. Here, I'm going to multiply by negative 3g. So negative 3g times negative 5g is positive 15g squared, because it's a g plus another g is 2 g's being multiplied. And then negative 3g times 3 is negative 9g. Now I come back and look, can I combine any like terms? Well, I have a negative 2g squared and negative 21g squared and 15g squared. That's negative 6g squared. I have 6g plus 6g plus negative 9g is 3g. I just have the 1g cubed term, but since it has the largest variable, it's going to get listed first. And then I have the plus 3. So as we're doing this, we're going to write the variables so that our variable with the highest exponent, the highest degree goes first, and then we're going to kind of go down the list. All right, next one. 4n times 3n squared is 12n cubed. 4n times n is 4n squared. Remember, you're multiplying the numbers, you're adding the exponents. And then 4n times negative 4 is negative 16n. Here, I have negative 1n times 3 is negative 3n. And then negative 3n. And then negative 1n times negative 1n is positive n squared. Now I look for any like terms. So I have 2 terms that are n squared. So that gives me 5n squared. The n cubed is all by itself, so it's going to stay out front. And then I have 3n, or negative 3n, and negative 16n. That gives me negative 19n. All right, last one real quick. We want to know in these two cases, Kevin and Carla each did the problem, negative 2x times 4x minus 3. We just want to know who did it correctly. Well, negative 2x times 4x is negative 8x squared. Negative 2x times negative 3 is positive 6x. So in this case, Carla did it correctly. It looks like Kevin missed the negative times a negative, which would make it into a positive.